In the present discussion, we have to derive Laguerre differential equation and polynomial. For that, take this equation x into d square y by dx square plus 1 minus x into dy by dx plus n into y equal to 0. So this is the required equation to get our Laguerre differential equation. Now the solution of equation 1 is y equal to summation ar x power k plus r, where r equal to 0 to infinity in this equation 2. This is the solution for equation 1. Now find out the value of dy by dx. dy by dx equal to ar k plus r x power k plus r minus 1. Ar is kept as such, this k plus r comes forward, then x power k plus r minus 1. This is the value of dy by dx. In the second order differentiation, d square y by dx square is ar k plus r minus 1 x power k plus r minus 2. This is the value of d square y by dx square. Now substitute d square y by dx square, dy by dx and y in equation 1. X into ar k plus r minus 1 x power k plus r minus 2. This is the value of d square by dx square plus 1 minus x into ar k plus r into x power k plus r minus 1 dy by dx value is this much plus n into the value of y is ar x power k plus r, entire is equal to 0. So this is equation 3. Just we have substituted the values of d square by dx square, dy by dx and y. Now we have to make a multiplication. This is ar k plus r minus 1 into x power k plus r minus 1. Actually this is x power 1, here x power k plus r minus 2. So the result is x power k plus r minus 1. A power m into a power n equal to a power m plus n. X power 1 into x power k plus r minus 2. It is equal to x power k plus r minus 1. Then multiply 1 into this much. Summation over ar k plus r x power k plus r minus 1. 1 into this. Then minus x into this term. Minus summation over ar k plus r x power k plus r. Here x power 1 is present. X power 1 into x power k plus r minus 1 is x power k plus r. Then write down this term plus n into summation of ar x power k plus r equal to 0. Now I have to combine x power k plus r minus 1 terms. First take ar outside, then k plus r Here k plus r minus 1. Here one term is present. K plus r. Entire is multiplied by x power k plus r minus 1. See here? We have taken out x power k plus r minus 1 outside and ar outside. K plus r into k plus r minus 1. Then here plus k plus r. Minus summation over ar. Here k plus r. We have taken out minus ar as a common term. So minus n. Entire is multiplied by x power k plus r is equal to 0. So this is equation number 4. We have taken out this x power k plus r minus 1 outside and ar outside. These two terms are present plus this term. Here we have taken out minus ar outside. So k plus r minus n. Entire is multiplied by x power k plus r. That is equal to 0. Now see here. This is summation over ar. Take this k plus r as a common term. K plus r. If you take out k plus r as a common term, we may get k plus r minus 1 plus 1. See here. We have taken out k plus r outside. K plus r minus 1. We have taken out k plus r. So plus 1. This is multiplied by x power k plus r minus 1 minus summation over ar k plus r minus n x power k plus r equal to 0. Now I have to simplify this further. Now the above equation is modified in this form. So this equation k plus r minus 1 plus 1 is k plus r. So ar into k plus r into k plus r entire is multiplied by x power k plus r minus 1 minus summation over ar k plus r minus n into x power k plus r is equal to 0. Here r equal to 0 to infinity. Here also r equal to 0 to infinity. Now we may write this ar into k plus r whole square into x power k plus r minus 1. K plus r into k plus r whole square. This ar k plus r minus n power x power k plus r equal to 0. This is equation 7. In equation 7, put r equal to 0. We can get a0 k square. R equal to 0 means k square. Then x power k minus 1. X power k minus 1 minus a0 k minus n x power k equal to 0. You get in equation 8. On equating the coefficient of x power k minus 1 to 0, we get this. We are in the position to equate the coefficient of x power k minus 1 to 0. Then a0 into k square is equal to 0. This is equation number 9. Here a0 not equal to 0, therefore the value of k equal to 0. K square is equal to 0, then k equal to 0. Now in equation 7, put r equal to r plus 1 in the first term alone. In equation 7, we have to put r equal to r plus 1 only in the first term, not in this term. This term should be written as such. Just we have to replace r by means of r plus 1. See here, is a r plus 1, k plus r plus 1 square, then x power k plus r. If you replace r by means of r plus 1 minus 1 r, then write out the second term as such. ar k plus r minus n x power k plus r equal to 0. Say this is equation number 10. Now we have to equate the coefficient of x power k plus r to 0. On equating the coefficient of x power k plus r to 0, we can get this equation 11. A r plus 1 k plus r plus 1 whole square minus summation over a k plus r minus n equal to 0. Summation of a r equal to 0 to infinity. Here also summation of ar plus 1 limit varying from 0 to infinity. Here a r plus 1 into k plus r plus 1 whole square, which is equal to k plus r minus n into ar. From this, ar plus 1 equal to k plus r minus n whole divided by k plus r plus 1 whole square into ar. This is the value of a r plus 1. See, this is equation number 12. But we know the value of k equal to 0. We know that k equal to 0. Therefore, a r plus 1 equal to r minus n divided by r plus 1 whole square into ar. This is the value of ar plus 1. See this equation 30. Now we have to put the value of r equal to 0, r equal to 1, r equal to 2, and so on. In equation 13, put r equal to 1. Sorry, put r equal to 0 first. R equal to 0. If you put r equal to 0, you can get the value of a0. a0, which is equal to minus n divided by 1 square. 1 square is 1, no need to put minus n into a0. This is written as minus 1 into n a0. That is minus 1 power 1. Write down here. a0 equal to minus 1 power 1 n into a0. This is nothing but minus in a0. Then put r equal to 1. If you put r equal to 1 in equation 13, we can get the value of a2. a2, which is equal to 1 minus n divided by 1 plus 1 whole square into a1. This is equal to minus of n minus 1. This 1 minus n is changed as minus of n minus 1 divided by 2 square. 1 plus 1 2 square into a1. The value of a1 is minus n s0 minus to minus plus, so n into n minus 1 a0 divided by 2 factorial square. You know that 2 square is 4, 2 factorial is also 2. 2 factorial square is also 4. This is value of a2. For simplicity, we can write a2 equal to minus 1 square. See here, minus 1 square is plus 1. N into n minus 1 divided by 2 factorial square into a0. This is value of a2. Then put r equal to 2. We can get a3. If you put r equal to 2, a3 equal to 2 minus n whole divided by 3 square into a2. This is equal to minus of n minus 2 divided by 3 square. Then the value of a2 is this much. N into n minus 1 a0 divided by 2 factorial whole square. And this is modified as a3, which is equal to minus n into n minus 1 minus n into n minus 1 into n minus 2 whole divided by 3 factorial square. See here, 3 square is 9. 2 factorial is 2. This is 4. 9 into 4, 36. 3 factorial is 1 into 2 into 3. 6. 6 square, 36. So that we may combine these two terms in terms of 3 factorial square. This is multiplied by a0. Now, this minus is changed in the new form. Minus 1 whole cube. Minus 1 whole cube is minus 1. N into n minus 1 into n minus 2 divided by 3 factorial square into a0. This is the value of a3. Now you have to combine all these terms to get the value of y. So you have to use the general solution. Y equal to summation over r equal to 0 to infinity ar x power k plus r. Then if you put r equal to 0, a0 x power k. R equal to 0 means x power 0, 1, so x power k. Then r equal to 1, a1 x power k plus 1. R equal to 2 means plus a2 x power k plus 2. R equal to 3 means a3 x power k plus 3. Here r equal to, here k equal to 0. In our case, the value of k equal to 0. So this is modified as a0 plus a1x plus a2 x square plus a3 x cube. Then y equal to a0 plus the value of a1 is available with us. That is minus 1 power 1 n a0. This much should be multiplied by x. a1 into x plus the value of a2 is minus 1 square n into n minus 1 divided by 2 factorial square a0. This is the value of a2 into x square. Then substitute the value of a3. The value of a3 is available with this plus minus 1 cube n into n minus 1 n minus 2 a0 divided by 3 factorial square. 3 factorial square. This is multiplied by x cube. In this way, the series is going on. Say this is equation 14. In equation 14, take out a0 outside. Y equal to a0 1 plus minus 1 power 1 x. This is nothing but 1 minus x. This is 1 minus x. 1 minus x, 1 minus nx. We have taken out a0 alone outside. If you take a0 outside, this is 1. This is minus n into x. This minus 1 square is plus n into n minus 1 divided by 2 factorial square x square is minus n into n minus 1 n minus 2 divided by 3 factorial square x cube. Then the series is going on. Now entire is present in simple form is 0 summation of r equal to 0 to infinity. This is r factorial divided by r factorial square n factorial n minus r factorial to x power r. Just we have to verify this. If you substitute the values, we may get all the terms one by one. We have to verify it. Oh, this equation is whatever as minus 1 power r. Instead of r factorial, we have present minus 1 power r. Now, if you substitute r equal to 0 in this equation, say this is equation 15, this is x power r. In equation 15, if you put r equal to 0, minus 1 power 0, 1, here n factorial, x power 0, 1, 0 factorial, 1, here r equal to 0. R equal to 0 means we make it n factorial divided by n factorial. Cancel row. So we make it a0. See here, first term a0 we can have. Now put r equal to 1 minus 1 power 1 minus 1. Then n factorial divided by 1 factorial square is 1. Here n minus 1 factorial. X power 1 is x. N factorial divided by n minus 1 factorial, which is equal to n. N factorial divided by n minus 1 factorial is 1. N. So for example, put n is equal to 3. Then n minus 1 is 2. N factorial divided by n minus 1 factorial. We have to calculate. N equal to 3. 3 factorial divided by n minus 1. That is 3 minus 1 is 2. 2 factorial. 3 factorial is 1 into 2 into 3. 2 factorial is 1 into 2. So we can get 3 as answer. So n factorial divided by n minus 1 factorial is n. We may get minus ns. If you put r equal to 1 minus 1 power 1 minus n factorial divided by n minus 1 factorial is n into x. So the minus 1x we can get the second term. In this way, for different values of r, we can get the entire series. So the value of y is equal to a0 summation or r equal to 0 to infinity minus 1 power r n factorial divided by r factorial square n minus r factorial into x power r. The above relation is modified in this new form. If n is a positive integer and the value of a0 equal to 1, we can get our Laguerre polynomial. We can get our polynomial. Here the Laguerre polynomial of n. If n is a positive integer and a0 equal to 1, the Laguerre polynomial of order n is without a0, just a0 equal to 1, we have to write r equal to 0 to infinity minus 1 power r n factorial divided by r factorial square n minus r factorial to x power r. This is x power r. This is the value of Laguerre polynomial. If you want to get the equation, then y equal to a into ln of x. That's all about our Laguerre differential equation and polynomial.